Hello students, good evening. So welcome to the session 13 of work, energy and power topic. So we are discussing about the head-on type of collisions, correct? So in the previous session, right, in the head-on type of collisions, we have covered the first subcategory, that is the perfectly elastic type, okay? So in today's session, we will continue our discussion about the other subcategories. Okay, so we are going to look at the inelastic collision in case of the head-on category, and also we look at the special case where we will be having maximum kinetic energy loss. That is what we call as perfectly inelastic type or plastic type. Okay, so we'll start the discussion with inelastic head-on collision. Now, whatever may be the type of collision, right? So here we are mostly talking about what? The collision of two masses, correct? So let us say we have a particle of mass m1 and another mass m2. Let us assume that their initial velocities are what? u1 and u2. Of course, head-on means they will be in one line, but we have to choose the velocities by following the sign convention. One line means still we can have two possible directions. Like if it is a horizontal line, right, we can have right side as well as left side, correct? Now, if you apply the conservation of momentum, because that can be applied for any type of collision, right? So if v1 and v2 are the final velocities of the respective masses, what will be the law of conservation of momentum? m1 u1 plus m2 u2 will be equal to what? m1 v1 plus m2 v2. So this can be used for any type of collision, so it can be used for the inelastic type of collision also. Okay, now what will be the other relation we can have? Because here we will be having two variables, right? v1 is unknown, v2 is an unknown. In case of the perfectly elastic, we were able to use the conservation of kinetic energy formula, but here we cannot use it. Why? Because here there will be no conservation of the kinetic energy, correct? Conservation of kinetic energy will not be satisfied. Then what will be the other relation we can think of here? The other relation will be coming from the coefficient of restitution, because to solve for these two variables, right, we will be requiring two equations. Only one we have, which is coming from the conservation of momentum. What will be the other one? The other one has to come from the coefficient of restitution formula. What is it? What is the coefficient restitution formula? E is equal to what? Relative velocity of separation after the collision divided by the relative velocity of approach before the collision. That is what? v2 minus v1 by u1 minus u. So from here what we can, if you cross multiply, means E into u1 minus E into u2 is equal to what? v2 minus v1. So this is like our equation 1. This is like our equation 2. Now how many equations we have? Two equations. How many unknowns are there? Two unknowns. Like the way we did before, right? We can solve for the v1 and v2 values. We are actually skipping that step. Okay, so from the two equations, right, we can solve for the v1 value and v2 value. Okay, we are not going through that solution part. We will just look at what will be the final results. Okay, this is simple linear equations in two variables. That's it. Like the way we already did in the case of the perfectly elastic, right? There also we have got two equations. Here also we have two equations. But when you look at the velocity formulas, right, you will see something. They will be looking almost similar to the velocity expressions that we have in the case of the head-on perfectly elastic. Remember what were the formulas we have there? v1 is equal to, maybe I will use a different color marker to write it so that we will be able to see that. So what is the formula we have in case of that perfectly elastic head-on type? v1 is equal to what? m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. So you'll see something interesting. What is it? In place of this m1 in the previous formula, right, we are getting what? In place of m2 we are getting E into m2. Second term, right, This is 2m2. In place of 2, what we will get? 1 plus E. Why? Because in the previous case, in case of the perfectly elastic head-on collision, right, E is equal to what? 1. Okay, so in fact, you look at this formula, right? You look at these two formulae in this. By the way, I'll write the V2 formula also. What is V2 formula? 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. This is the V2 formula. Now, the way we will be able to get the previous result, because the previous result we already remember. We kept on saying that we have to try to remember those two formulae as much as possible. You look at this one, right? In these expressions, substitute E is equal to 1. If you put E is equal to 1 means what? The formula is going to give us the velocity expressions in case of the perfectly elastic head-on type. Why? Because for the perfectly elastic head-on, E is equal to what? 1. You can check it. If you put E is equal to 1 means we'll get those formulae. Okay. So these are the velocity expressions for these two particles after the collision. Okay, you can see the velocity expressions will be looking similar, but you are going to get the factor E. Okay, so when you're trying to remember it, right, either you remember the previous two velocity formulae and see where you will bring the E factor, or you remember these two formulae. If you remember these two means, whenever we are looking for the velocity expression for the perfectly elastic head-on, right, we will just keep E is equal to 1. Okay, so either ways, whichever you are comfortable. But remembering these formulae, right, will actually help us to get the answers fast. Now, in case of this inelastic head-on collision, we can also solve the problems without remembering these formulae. Why? Because we have the two equations, right? For every question they give us, they will have to give us all the variables other than V1 and V2 in those two equations, right? They have to give us all the variables. So instead of remembering these formulae, we can also make one more plan. What is it? If you are like somebody who hate remembering the formula, right, what you can do? You can try to make up your mind so that for each and every question, right, you will just write down the basic equations. Conservation of momentum equation, quotient of restitution formula. You write those two equations, solve by using those two equations. Like that also we can practice. Okay. Now when we say inelastic, kinetic energy is not conserved. So definitely the next thing that will come to our mind is what will be the loss of kinetic energy, because we said in almost all the inelastic that we are going to discuss, we will have kinetic energy loss scenario, because we even said inelastic means what? Initial kinetic energy is not equal to final kinetic energy, but generally what is it going to be? Loss. When there will be a gain of kinetic energy, we said some exceptional cases when some of the internal energy of the particles is converting itself into kinetic energy form. That will be rarest of the rare cases. Okay, but most of the cases that we discussed, right, like these the normal collisions, kinetic energy will be lost in the form of heat, sound, etc. Okay, now what will be the loss of kinetic energy? What will be the loss of kinetic energy? It will be the initial kinetic energy total value minus final. Initial means what? M1 will have kinetic energy half M1 U1 square. M2 will have kinetic energy half M2 U2 square. Add both of them. From that we have to subtract the final kinetic energy half M1 V1 square half M2 V2 square. Here we are going to get one more formula, because already we are having V1 and V2 expressions in our hand. V1 is there, V2 is there. If you actually substitute V1 and V2 in that formula and simplify, again we are skipping this derivation. Okay, we'll just look at the final result. We are going to substitute the values of V1 and V2. If you substitute the value of V1 and V2, then what we will be getting is the expression for the loss of kinetic energy. What is it? Half times M1 M2 by M1 plus M2 into 1 minus E square into U1 minus U2 the whole square. So here you can see one thing very clearly. If E is equal to 1, look at the formula. V is equal to 1. What is the loss of kinetic energy? 0. That is our perfectly elastic category, right? So look at this. This is another. What is this? This is a formula for loss of kinetic energy. Okay, so here we are getting three formulae: velocity 1, velocity 2 for the particles after the collision, then the expression for the loss of kinetic energy. Okay, sometimes maybe JE means we might have some straight questions asked about the loss of kinetic energy. What is the loss of kinetic energy formula? Half m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 the whole square. Okay, so this is about the inelastic head-on collision. Now what kind of questions will be asked in that we will see, but before we go to the questions, right, there is one very interesting example for this inelastic head-on type of collision, that is the rebounding of the ball after collision with the ground. Let us say, for example, we are this is the ground. Okay, so we are dropping a ball from a height h0. Okay, so just we are dropping the ball. When it comes to the ground, it will have a velocity. Let us say the velocity is what? v0. What will be the velocity? It will be what? Root 2g h0, right? We have seen this in the kinematics. If you drop an object from a height h, by the time it is reaching the ground, what will be the velocity of that? It will be what? Root 2g h, correct? If you are dropping it from h0 means it will be what? Root 2g h0. Okay, so let us consider that we are dropping an object from a height h0. Then when it is striking, right, what will be the speed with which it will strike the floor? Root 2g h0. That is what we are calling as v0. Once it is striking the floor, what is going to happen? It will bounce back. Generally, what do we observe? It will not bounce back to the same height. It will bounce back to some lesser height. Let us call it as h1. So the velocity with which it is bouncing back after the first collision, let us call it as v1. The velocity with which it is bouncing back is what? v1. Now this is what example of head-on inelastic, right? So here we can talk about the quotient of restitution E. What is this? Relative velocity of separation. Here the floor is always at rest. Relative velocity of separation after the collision means what? With how much velocity it is going up? v1. Divided by relative velocity of approach before the collision means with how much velocity it is approaching? It is approaching with the velocity v0. Means from here what is the relation? The velocity v1 with which it will bounce after the first collision is what? v1 will be equal to, just to rearrange, v1 is equal to what? E times of v0. v1 is equal to what? E times of v0. Now with this v1 it is going up to height h1. With this v1 it is going up to height h1. So what will be the h1 value? v1 square by 2g, correct? Because if you throw an object with a velocity u upwards, how much height it will go up to? U square by 2g, right? These are the results that we have seen in the kinematics, vertical straight line motion. Okay, so v1 square means what? E square v0 square by 2g. E square, what is v0 square? v0 is root 2g h0, right? v0 square means, so what do we have? h1 is equal to E square into h0. Okay, so what is the result we are having? The height to which it will go after the first bouncing will be equal to what? E square into h0. Now it will go to that height h1. It will come down, correct? It will come down and it will be coming down. It will come down with velocity v1. Now it will again hit and bounce. Let us say it is bouncing with a velocity v2. With that it will go to a lesser height, even lesser height, h2. So again same thing, right? v2 will be equal to what? E times of v1. Now what will be the relation we have? E is equal to v2 by v1 will come. So v2 is equal to what? E times of v1, which means E times of what is v1? So what is it? E square into v0. So velocity after the first collision is what? E into v0. Velocity after the second collision is what? E square into v0. Like if you extend it, right, velocity after the third collision will be what? E cube into V naught. Velocity after the fourth collision will be what? E power 4 into V naught, like that. It keeps on going. That will keep on going. Okay. Now, what about the height to which it will go? Let us call it as h2, right? h2 will be equal to what? h2 will be equal to, here what we have, E square into h naught, that is h1. Okay. By the same analogy, right, it will be what? E square into h1. h1 is equal to E square into h naught. So h2 will be equal to what? E square into h1, right? So E square into what is h1? So what is it? E power 2 into 2 h naught. Then after the third collision, how much height it will go? Same analogy, right? Like look at the V3 value. V3 is equal to what? E cube into h naught. So this is h2. So h3 will be what? E power 3 into 2 into h naught. What about h4? E power 4 into 2 h naught. Like that. Okay. When you try to generalize it after the nth collision, like this, we are having collisions continuously. After the nth collision, right, the velocity, so like we are releasing from a height h naught. By the time it is coming to hit the ground, the velocity is what? V naught, velocity or speed. Okay. It is having multiple collisions like this. After nth collision, n may be 2, n may be 3, n may be any general number. After nth collision, right, what will be the velocity of the ball? E power n into V naught. Like after first, what is it? E power 1. Second, what is it? E power 2. Third means E power 3. Fourth means E power 4. Nth means it will be what? E power n into V naught. Similarly, what about the height to which it will go? Because height to which it will go will be what? Whatever the velocity it is having after the nth collision, square of that value divided by 2g, right? Correct. So that will be equal to what? E power 2n into h naught. Like that also we have seen. After the first collision, right, it is going up to a height which is equal to E square into h naught. After second, it is going up to height which is equal to what? E power 2 into 2 h naught. Third, E power 2 into 3 h naught. Fourth, E power 2 into 4 h naught. Like that. General nth collision, after nth collision, what will be the height to which it will go? E power 2n into h naught. So these are two important results that will actually of use for us. Okay, in fact, in some of the previous year questions also, I think they have touched upon this idea. So after the nth collision, right, what is the velocity of the ball with which it will bounce, and what is the height to which it will go? So this is the case of rebounding of the ball after the collision with the ground. Now we can have questions like this, where the questions, like I said, right, questions can be solved in case of this inelastic head-on type, right? We can solve the questions either by using, like we'll just read the question. No, ball moving with a velocity 2 meters per second collides head-on with another stationary ball of double the mass. So they're not even telling. So let's say we have a mass m, another 2m. It is moving with a velocity what? 2 meters per second. This is at rest. If the quotient of restitution is 0.5, then their velocities after collision will be. Means we have to tell what is the v1 value and v2 value. u1 is given, right? u1 is what? 2. u2 is, it is at rest means what? 0. u1 is 2, u2 is what? 0. We have to find what is v1 value and what is v2 value. So how do we do it? Like I said, right, if we remember those two velocity expressions, v1, v2 expressions, right, we can straight away look in that formula. E is given to us. E is given as what? 0.5. M1 and M2 are not given, but they are saying first ball and second ball is having double the mass. So we took first ball to be having a mass m, second ball will have a mass 2m. That m and 2m will get cancelled. Finally, that m term will not come in the answer. So when you substitute there, right, u1 is 2 meters per second, u2 is equal to 0. Substitute them, we will be able to get what is the V1 and V2 values. So let us just substitute them. What we'll have, see here the thing is U2 is 0, so straight away this is 0. Here also this is 0. Okay, so now look at this. V1 will be what? M1 M minus E into M2. E is what? 0.5. 0.5 into 2M means that is also M. Divided by M1 plus M2 is what? 3M. Into U1. U1 is what? 2 meter per second. But M minus M is 0, right? So that will be 0. So the mass M will be coming to rest after the collision. Now let us look at the V2. What will be V2? 1 plus E means what? E is 0.5. So that is 1.5 into M1 divided by M1 plus M2 means what? That is 3M into U1. What is U1? 2 meter per second. So look at this. What do we have? This is M get cancels. 1.5 into 2. What is it? 3. There is a 3 in the numerator, 3 in the denominator. So what is it? 1 meter per second. So V1 is equal to 0 and V2 is equal to 1 meter per second. That's it. So what is the correct answer for this? If you remember these two velocity expressions, right, we will be able to get the answer that quickly. If we don't remember it, then what do we need to do? Because if it's sometimes, we may think we are able to remember the formulae, but only in the final examination, right, we will be still little bit jittery whether the formula that we remember is correct or not, or is there any alternative approach. What is the alternative approach for this kind of cases? The basic equations. What are those? Conservation of momentum. So we have to apply the conservation of momentum. That will give us one equation. Second equation will be what? The quotient of restitution formula. What is it? V2 minus V1 by U1 minus U2. Two equations. Like we will get the two equations as it is. Solve them, we will be able to get what is the V1 and V2 values. By solving them, we will be able to get what is the V1 and V2 values. That way also we can do. Either we remember the formulae or we use the original approach. Okay. So what is the original approach? The original approach is that we will just go and use that conservation of momentum. Maybe if you want, you can even check it now. We will not get different answer. We have to get the same answer. Because whatever, in fact, how did we get this V1, V2 formulae? V1, V2 formulae we are able to get from those equations only, right? V1, V2 expressions, how did we get them? We are able to get them from the conservation of momentum principle and then quotient or restitution formula, correct? So we can even go and use those two equations in any given problem. Like that also we can approach. Okay. So we'll just have to little bit, if you want to remember, see, like a lot of people think, right, so whenever you have a formula or an expression, you will not be able to remember it just by trying to sit and memorize. Even if you remember it for some time, it will just go away easily. The best method to remember them is keep practicing as many problems as possible on that particular expression or the formula. So if you want to remember these velocity expressions, means try and do a couple of more questions so that you will be able to remember it. But the thing is, at least in the recent years, right, the way they are framing questions in JEE mains, even in the JEE advanced, they are not expecting us much to remember these kind of formulae. Okay, so the kind of question they are framing, we will be able to do those questions without even really required to remember these velocity expressions. But remembering them will always give us an advantage. Okay, we'll move on to the next one. Let us see this one. This is another interesting question. A particle moving with a velocity small v. Here we should not confuse. There are two velocities. Small v is there, capital V is there. Okay. Particle moving with a velocity small v in the positive x direction has an inelastic collision with a wall moving in the opposite direction with a speed capital V. See, wall is what? Heavy mass. Wall is a heavy mass, right? Now, here we have not mentioned this special case, but heavy mass like the way we have discussed in the case of the perfectly elastic special cases, right? Heavy mass after collision, its velocity will not be impacted. Heavy mass after the collision, the velocity will not be impacted, means wall velocity will not change after collision. Okay. The coefficient of restitution is what? E. The coefficient of restitution is what? E here. If the speed of the ball remains same after collision, they are saying, understand carefully, they are saying speed of the ball, this is the ball, right? How can speed of the ball remain constant or remain same after the collision? It cannot go to the other side of the wall because it cannot go into the wall, right? Means after collision, the ball must be moving with same speed small v but in the opposite direction. So as per our convention, right side we take positive, means left side will become what? Negative. Okay. So we need to find what is this capital V value. So we have to get the capital V value. It's a very basic question using the coefficient of restitution idea. Okay. So look at this. We will just try to represent these velocities. Let us call the ball as 1 and the wall as 2. Okay. What is U1? U1 is equal to V. U2 is equal to, wherever it is capital V, right, I will write with a black color. Okay, so this is what is U2, it is a minus capital V, so that we will be able to see the difference. That is capital V. Okay, then what do we have? What else we have? We have the V2. After collision also the wall velocity will not change because that is the heavy mass. So this is something that we can take, heavy mass, right? After collision, the velocity will not be impacted. So that is again minus capital, that is not changing. What is the V1 value? That is the velocity of the ball after the collision. V1 is what? Minus small v. See, black color I am writing the capital V, that is the wall velocity. Okay. Small v is the velocity of the ball. Now these are the U1, U2, V1, V2. What is the quotient of restitution formula? E is equal to what? V2 minus V1. Correct. What is the formula? V2 minus V1 by U1 minus U2. That is the E formula, right? So check it. What is it going to be? V2. V2 means what? Minus V, capital V, that is the wall, minus V1. V1 is what? Minus small v, divided by U1 minus U2. U1 is what? V, minus U2 is what? Capital V. So look at this, what do we have? Wherever you have minus into minus, it becomes what? Plus. Correct. So this is what? Minus into minus becomes plus. Here also minus into minus becomes what? Plus. So what is the thing that we have here in the numerator, right? We have small v minus capital V. Denominator we have small v plus capital V. Numerator what do we have? Small v minus capital V. Denominator we have small v plus capital V. That is our E value. Okay. Now we have to get the capital V formula, right? What do we need to get capital V value in terms of the other things? So here we can see it like, we can use the ratio proportion method, right? It's like what? LHS E by 1. So if you use the ratio proportion method, what we will get? This side, if we do E plus 1 by E minus 1 on the left side. Right side, what is it? We have to add both these things, right? If you add both of them, means numerator, what do we have? Numerator will be having 2 small v. Denominator, we have to subtract, right? If you subtract, means look at this. If you do the first term, numerator minus denominator, what we will get? We will be getting minus 2 capital V. 2 will get cancelled. So it's just that, it is involving some steps, that's it. Okay, so from here what we'll have, if you cross multiply, right, what do we have? We are looking for the capital V, right? So let us just write down the capital V value. Capital V is equal to what? 1 plus E by 1 minus E. Okay, what is capital V value? 1 plus, just I'll erase the space so that we can see them. So we'll just erase it. So here what do we have? E plus 1 by E minus 1 is equal to small v by, I'll always use the black color for the capital V, minus capital V. We are looking for capital V, right? Let's just bring it to the left. Take everything to the right. Okay, so capital V will be equal to what? What is capital V value? It will be equal to what? E minus 1 by E plus 1, because this will go to the numerator, E plus 1 will come to the denominator, into small v divided by minus 1, which is what you multiply numerator and denominator with minus 1 means it will be what? 1 minus E by 1 plus E into small v. Check it, guys. What is the answer? It will be what? 1 minus E by 1 plus E into small v. I mean, the only thing that will be a little bit confusing here is sometimes, we may expect these kind of questions. It's not like they will not give purposefully itself, right? They might frame such a question so that, while doing the calculation, we ourselves will be confused as to which V we are using. Okay, so just need to be careful with questions like that. Okay, so you can see even in some of the past year JEE Advanced, right, they would have given such questions where they might use the same variable form. One is small x, other is capital X, like that. Okay, so only when we practice some questions like that, we will be able to see what is the kind of a challenge in solving these kind of questions. It's not a tough question. It's not a tough question, right? In case, you want to do away with this capital V, small v confusion. Anyway, they are asking us capital V, right? So what you could do is, I wanted to show you the procedure so that we will be able to understand how do we tackle it. What we could already know, because anyway we are trying to find the capital V value, right? From the beginning itself, we would have said this is minus x. Instead of saying minus capital V, let us say minus capital X. Now the entire confusion is gone because we will not have two velocity terms. Okay, so like they are saying, right, if you want to feel the warmth inside, you have to go outside and expose yourself to the cold. Then only you will be able to understand what is the comfort inside the house, right? So same way, we already solved by using that capital V, small v. Now the same problem, if you want to just avoid this confusion, right, what you can do, just in place of that capital V, use a variable x. Everything will be very simple. Okay, so this is a question based on what? Straight using of that quotient of restitution result. And here, right, one more thing that we are able to get, what is it? The heavier object. That special cases we discussed in the case of the perfectly elastic collision. The heavier object, after collision the velocity will not be impacted. Okay, so this is about the kind of questions we will be able to expect. Now, what kind of questions can come in this multiple answers type? So when you're looking at the JEE Advanced, right, we can have some questions like this. In the figure shown below, quotient of restitution between A and B is half. So A is moving with a velocity v, B we will take it to be at rest. So initially what is happening? A is moving with a velocity v, B is at rest. Okay, what is the quotient of restitution? Half. They are giving us 4 statements. Velocity of B after collision, impulse between the two objects during the collision time. What is impulse? Change in momentum, right? So impulse is what? Change in momentum. For any particle you have to calculate change in momentum. Okay, then option C and D, they are talking about the loss of kinetic energy. So how do we proceed? How we have to proceed? Same way, right? We will have to get the velocities of the particles after the collision. We have to get the velocities of the particles after the collision. Okay, so again I said, either we remember those velocity expressions or we go by the general approach. What is general approach? Let us say this velocity is v2, this is v1. What is u1? u1 is v, u2 is equal to 0. Both of them have the same mass m. Okay, first equation is what? Conservation of momentum, means m1 v1 plus m2 m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Both of them have the same mass. Okay, so look at this, m into v is equal to m into v1 plus v2. So from here what we'll get one equation. What is it? v1 plus v2 is equal to v. That is our equation 1. How are we getting it? By using the conservation of momentum. Okay, now let us use the quotient or restitution formula, right? E is given as half. Half is equal to v2 minus v1 by u1 minus u2. So from here straight away what we will get? Just bring the v to the left. v by 2 is equal to v2 minus v1. That is our second equation. Okay, so v2 minus v1 is equal to v by 2. Two equations we have to solve for two unknowns, right? Two equations are there, we have to solve for two unknowns. Check it, how we will be able to solve for them. How do we solve for them? If you just add both the equations, right? Just think about adding both the equations. If you add both of them, what is going to happen? The v1 and minus v1 will be cancelled. Add 2v2 is equal to, right side is what? V plus v by 2, 3v by 2. So from here we will get v2 is equal to what? 3v by 4. So option A, what are they saying? Velocity of B after collision is v by 2. Is it correct? No, because v2 is what? Velocity of B after collision, right? What is the value coming as? 3 times v by 4 it is coming. See, if v2 is 3 times v by 4, look at this, we are able to get v2 value 3 times v by 4. What is v1 plus v2? V, right? Which means v1 has to be what? V by 4. v1 has to be what? V by 4. Okay, so now we are able to get what are the velocities of these A and B after the collision. Okay, so first statement we are able to conclude that is incorrect. But what about the option B, impulse between the two objects during collision? Means let us take any of them, right? For B, because impulse force acting on B will be numerically same as impulse force acting on A, because impulse is what? Internal force. For B, right, impulse means what? Change in momentum, right? What is change in momentum? What is change in momentum for that? Its final momentum is what? M into 3v by 4 minus initial momentum is 0 because it is at rest initially. So what is it? 3 by 4 mv. Is it correct? The impulse acting on B is what? 3 by 4 mv. That will be same as impulse acting on the A also, because impulse force is that internal force, right? So option B, it is the correct one. So remember, this is what? Multiple answer. We'll have one or more options being correct. Okay, so now the thing is about the kinetic energy, because we are done with the velocities, we have checked the impulse, because you see this question, right, it is like 3 questions put into one. It is like what? 3 questions given into one particular question. Okay, option C and D, both of them are talking about the kinetic energy loss, right? What is the initial kinetic energy? Because only that A is having kinetic energy initially, half m into v square. What about the final kinetic energy? Half into m into, what is the velocity of the first particle? V by 4 the square. Again half into m into, what is velocity of the second particle? 3v by 4 the square. So we have to be careful here. Huh? So what is it? So we can take out half m common. This is what v square by 16, that is 9v square by 16, totally 10v square by 16. Okay, so that is what 2 5s are 2 8s are, so totally what do we have, 5mv square by 16. So initial kinetic energy is what, half mv square. Final kinetic energy is what, 5 mv square by 16. Okay, they're asking us what is the loss in kinetic energy. Okay, so what is the loss in kinetic energy, half mv square minus 5 mv square by 16. Check it, what is the match, is it matching with any of them? So what is it? What is the LCM of the denominator? 16, right? So we'll have 16. This is what, 8 mv square minus 5 mv square. That is going to be what, 3 mv square by 16. Do we have an answer? Loss of kinetic energy is what, 3 mv square by 16. So option C is also correct. Obviously option D will be wrong. Why? Because both are talking about the loss of kinetic energy, right? Loss of kinetic energy is coming as what, 3 mv square by 16. Okay guys, so you have to check whether you are able to get this answer or not. Okay, so we are done. We will go into the next type, which is the perfectly inelastic in the head-on collision. Perfectly inelastic is what? It is a special case where we'll have the kinetic energy loss to be maximum. The kinetic energy loss to be what? Maximum. Okay, so in this perfectly inelastic scenario, what is going to happen is that two objects, while they will be moving with different speeds before the collision, after the collision they will stick together and move with a common velocity. So if they are sticking and moving with a common velocity, right? So understand carefully, this sticking and moving is only when we are talking about the perfectly inelastic collision in the head-on type. The head-on type collision, if they stick and move together with a common velocity, right, that is when we will be having the kinetic energy loss to be what? Maximum. And we can find out what will be the common velocity. How do we find out? Straight away use the conservation of momentum principle, right? Initially what is it? m1 u1 plus m2 u2. Initial momentum is equal to what? Finally both of them are moving with a common velocity, that is our v common. So what is it? V common is equal to what? What is the common velocity? m1 u1 plus m2 u2 by m1 plus m2. m1 u1 plus m2 u2 by m1 plus m2. That's it. So that will be the final velocity with which both these objects will be moving after the collision. Okay, so this is a very straightforward result. All we need to do is what? The conservation of momentum. Okay, so here we don't need to remember any equations or anything, just we have to use the conservation of momentum, because after collision both these objects will stick and move. So in this case, right, what will be the coefficient of restitution value? Because they are sticking and moving together means v1 is equal to v2, right? What is the E formula? v2 minus v1 by u1 minus u2, correct? So v2 is equal to v1 means numerator will be 0. So for the perfectly inelastic head-on collision, what is the E value going to be? E will be what? 0. Okay. Now because we are talking about the special case where the kinetic energy loss will be what? Maximum. Talking about the special case where the kinetic energy loss will be maximum. What will be the value of that? Okay, so already we have talked about the expression for the kinetic energy loss. See, here there are two ways of doing it. Already we have the expression for the kinetic energy loss, right? In this expression, if it is the perfectly inelastic case, then E will be taken as what? If it is a perfectly inelastic, means E will be what? 0. So just substitute the E value 0, what we will get? Half m1 m2 by m1 plus m2, 1 minus E square means 1 into u1 minus u2 the whole square. So this is what is the expression. So the loss of kinetic energy formula already we have, right, for the inelastic type. In that, just replace E is equal to what? 0. That's it. Either we will use this method, or we are already getting the V common, means we know what will be the kinetic energy of the particles after the collision. Initial kinetic energy will be known to us. Just we have to subtract the final kinetic energy value from the initial. What do we need to do? Loss of kinetic energy means we have to do Ke initial minus Ke final. How do we know Ke final? Based on the common velocity expression. Okay, so either we remember this loss of kinetic energy for the inelastic collision, in that substitute E is equal to 0, because for the perfectly inelastic head-on type, right, E will be taken as what? 0. That is one method. Or the basic approach, what is it? We are already getting the common velocity, right? Using that, find out the final kinetic energy of particles. Just do initial kinetic energy of particles minus final kinetic energy. The general approach. Okay, that way also we can find what is the loss of kinetic energy. But that is an important question here, because after all, what is it? It is a special case where we will have kinetic energy loss to be maximum, right? So that's why we have scope of getting questions on that. Okay, so this is about the perfectly inelastic head-on type of collision. So typically, like, if you are having a bullet or something, when you fire it, it will go and stick onto the target, and they will keep moving together. So all these are the examples we can think of for the perfectly inelastic head-on type of collision. So what happens? They will stick and move together. Okay, now we are again emphasizing this is only for the head-on type. Why? Because when we go to the oblique collision, there the objects always will not stick and move. In the oblique perfectly inelastic, right, oblique collision means the particles will be having velocities in different directions. In the oblique collision, right, the perfectly inelastic case, the objects need not stick and move. The sticking and moving together with a common velocity is only for what? It is only for the perfectly inelastic or plastic collision in the head-on category. Okay, and see, we can try to understand the way these three types of subcategories. Head-on collision, we have perfectly elastic, where the coefficient of restitution is what? 1. In case of inelastic, E value is between 0 to 1. In case of inelastic, right, E will be between 0 to 1. And perfectly inelastic, E is equal to what? 0. So that way we will be able to differentiate between these three subcategories by using the quotient of restitution values also. Okay, so this is about the perfectly inelastic or plastic collision in the head-on type of category. Okay, now we can see some questions. Two masses, 8 kg. What is the speed? 10 meter per second. 2 kg, 5 meter per second. Moving along the positive x-axis, means both of them are moving in the same direction. Look at this. This is the 8 kg. This is the 2 kg. 10 meter per second, 5 meter per second. You can see 8 kg is coming faster, so that it will be able to come and collide. Undergo perfectly inelastic collision. What is the kinetic energy loss in the collision? Okay, so first what we need to find, when they undergo perfectly inelastic collision, after collision they will stick and move with a common velocity. Sticking and moving means now total mass is what? 10 kg. It's like both of them are moving together, right? What is the initial momentum? Here when you are applying the conservation of momentum, we have to take care of the sign convention, right? Here we will take right side positive, left side negative. 8 kg is moving to the right, so momentum is what? 8 into 10, 80, plus 2 is also moving to the right, so 2 into 5 is what? 10. That is equal to, now the 10 kg will be moving with a common velocity v, so momentum is what? 10 into v. Left side, what is it? 90 is equal to 10v, which means v is equal to what? 9. Unit will be what? Meter per second. Now what do you mean by the kinetic energy loss? Kinetic energy loss means what? Initial kinetic energy minus final kinetic energy. What is the initial kinetic energy? Half into 8 into 10 square plus half into 2 into 5 square. That is what we can see. 10 square is what? 100. 800 by 2 means 400, plus this is what? 25. 425. Everything is in the SI system, right? So that will be what? Joule. That is the Ke initial. What about the Ke final? Half into 10 into V square. What is V? 9 square. Okay. That is how much? 2 ones are, 2 5s are. So 5 into 9 square is 81. That is what? 405 joules. So the loss means what? Here we are putting delta, but this is not change. This is what? Loss. Loss means always we have to do initial minus final. Initial is what? 425. Final is what? 405. Means what is the loss in the kinetic energy? 20 joules. 425 minus 405 means what it is? 20 joules. Okay. Now we look at one more similar question. Two masses 6 kg moving with 8 meter per second. 4 kg moving with 2 meter per second. Moving along the positive x-axis and negative x-axis respectively. Means they are not moving in the same direction. This 6 kg is moving in the positive. But what about the 4 kg? It is moving in the negative. So remember our sign convention. Right generally we will take positive, left we take negative. So it will be what? Minus. After they undergo collision, it's like what? 6 plus 4, 10. This will have a common velocity. That is what we need to find. Okay, so how do you find the common velocity? Same, conservation of momentum. What is the momentum of this? 6 8s are 48. Momentum of this is what? 4 into minus 2 is minus 8. That is equal to 10 into V. 48 minus 8 means 40 is equal to 10V. Means V is equal to what? 4. So the 10 kg will start moving in the positive direction. Means that is to the right side. With how much speed? 4 meter per second. Now same thing. What about the initial kinetic energy? Half into 6 into 8 square plus half into 4 into 2 square. You should understand one thing. When we talk about the kinetic energy, right, here the sign convention will not be required. Why? Because kinetic energy is a scalar quantity. Kinetic energy is what? Half into mass of the body into square of the speed or square of the velocity magnitude, right? That is why here no minus will come. Okay, so what is it? This is what? Half into 6 into 8 square means 2 3s are 3 into 8 square is 64 plus 8. 3 into 64 is what? That is 192 plus 8, that is 200 joule. That is our initial kinetic energy. We'll just write it here. What is the final kinetic energy? Half into total mass is 10. Velocity is what? 4. Means what is it? This is how much it is coming as? 2 1s are, 2 5s are. 5 into 16, that is how much? 80 joules. Now the loss in kinetic energy, what is it? 200 minus 80, that is what? 120 joules. Now you need to understand one thing. In the previous question, right, look at the value, how much it is coming as? 120. It's a lot of amount of energy loss. If you try to calculate in terms of the percentage energy loss, this will be what? 120 is the energy loss, divided by original energy is what, 200, into 100. The percentage energy loss will be very high here. In the previous question, right, if you try to calculate the percentage energy loss, what is it? Energy loss is how much? The previous case, what is the energy loss? 25, right? So look at this. This is the previous problem that we solved, right? Energy loss is what, 20. Divided by original energy is what, 425. So the percentage loss will be very less. So the thing that I want you to notice is, if this is a perfectly inelastic, means the kinetic energy loss in the given situation is going to be maximum. But even then, if the bodies are moving in the same direction, right, in that type of a plastic collision or the perfectly inelastic collision, the kinetic energy loss, if you try to calculate in terms of percentage wise, right, it will not be that much, it will be less. But whereas if you look at this situation where they are moving exactly facing each other, then in this case, right, you can see the percentage energy loss we calculate, it will be very high. One extreme example for this is, like, think about it, you have two masses. You have two masses which are coming towards each other with equal momentum. What do you mean by that? Let's say, for example, this is m1 coming with a speed u1, m2 coming with a speed u2, but they are in opposite directions. If the m1 u1 value is equal to m2 u2 magnitude wise, by magnitude, okay, then once they come and collide, right, we are talking about the perfectly inelastic. What is the initial momentum means? Because we have to add them like vectorially, right? So one we will take it as positive, other we will take it as negative. So when you add them vectorially, what you will get? 0. That will be equal to the total mass is m1 plus m2 into v, which means what we will get? V as 0. So once the collision is happening, nothing will move. They will just stick and stay there. They will be just sticking and staying there. So if you have two particles coming exactly facing each other with equal momentum value, like, what can be a simple example for this? Take two objects having mass m coming with velocity v, this side velocity v. They have equal momentum value, right? When they come and collide each other, if it is a perfectly inelastic head-on collision, what is going to happen? They will just come and stay there, that's it. Okay, so this is how we will be able to analyze the perfectly inelastic head-on type of collisions. Okay, so with this we'll hold the class here. In the next class, right, we will start with the oblique collisions. So oblique also we have to talk about the three subcategories: perfectly elastic, inelastic, and then perfectly inelastic. Okay, so we'll continue in the next class with the oblique type of collisions.